Hey friends, it's Miss Willis here, doing your Unit 3 videos. First one, Intro to Rational Functions. Is the quotient of two polynomials. Okay, so what does that mean? So an example would be f of x equals 2 over x plus 3. In order to be a rational function, you do have to have a variable in the denominator. So a variable in the denominator is what makes it, because if I flip this around, if I had it as x plus 3 over 2, that's not a rational function, because that's just 1/2 x plus 3/2, which is just a line. And that would just be a polynomial, okay? So making sure you have a variable in the denominator. So speaking of denominators, the domain of a rational function consists of all real numbers except for which the denominator is 0. All right. So let's talk about that by looking at the parent function. So the parent function, so let's write down the example. It would be graph the parent function f of x equals 1 over x. State the domain and range. All right, so we got this little parent guy. If we type this into our calculators, or actually just without a calculator, and we were to just look at where it causes issues. So if we looked at this, let's just make a table. We know that x cannot equal 0 because you can't divide by 0. That's not okay. It would be undefined. Okay, and this one's easy because there's no plus or minus or any of that stuff. So x can't be 0. So 0 is where my error is happening. If I were to type that in the calculator, it would be undefined. Error. I want to look at values on the other side and see what's happening. So like if I plugged in 0.001, if I plug that in, because that's just 1 over 1,000, 1 divided by that equals 1,000. And if I plugged in 0.002, that's 1 over 500. So if I divided that, it would just be 500. If I plugged in 0.003, that would end up being 33.3. Okay, well, let's see the negative versions. Well, it's going to end up being the exact same numbers, except they're going to be negative. But guess what? That's not just going to stop at 1,000 and negative 1,000. That makes 0 sense. If I plugged in 0.0001, it would get even bigger. If I just kept making that decimal really, really small, my y values would just be getting really, really bigger. So as I'm getting smaller and smaller and smaller, or getting closer and closer to 0, what is happening to my y values, y'all? What is happening? If they're getting really, really big, what does that mean? What does that mean? Oh my goodness, it means infinity. But on the other side, they're getting really, really big, but they're negatives. So that means negative infinity. That's my end behavior for when I'm getting closer to 0. Okay, so let's draw a picture of this. Make me a nice little X and Y axis. So so here's 0, the middle, the origin, right? As my little X values were getting closer and closer and closer and closer to 0, they were starting to shoot way up on the positive side. Should have done that in a different color. So as I'm getting closer and closer to 0, they shoot up. And on the other side, as I'm moving this way, they're starting to shoot down. Okay, so what is causing this to happen is we have some asymptotes. And I say it wrong, and Ms. Fisher corrects me all the time, but I can never remember what I'm supposed to call it. But I put in more syllables than I'm supposed to, I guess. This right here is y equals 0. That's our horizontal. And this right here is x equals 0. So let me highlight them. So the yellow one is your horizontal. That's y equals 0. And this blue one is your vertical, and that's x equals 0. So if I were to write the domain for this guy would be negative infinity to 0, but it's never going to equal it, so I'm using parentheses, and 0 to infinity. Same thing for range. They won't always match. Negative infinity to 0, union 0 to infinity. Now, when I'm grading y'all's stuff, y'all write this crazy. Brackets and parentheses. If it equals it, it has a bracket. Infinity's never going to have a bracket. You need to make sure you're putting unions in between. That's the symbol for and in math. Honors pre-calc, y'all. All right. Graphing by transformations. Graphing by transformations. Kind of easy, kind of not. You can't just look at it sometimes. If there's variables on the top and the bottom, it becomes a little tricky. Okay, so let's start with an easy one. Okay, so number 1, f of x equals 2 over x minus 3. Okay, so what's supposed to be on top is 1. If 1's not on top, we got other things going on. So in order to make this a 1, all that would happen is that this guy would be the same thing as if I took a 2 out and it was 1 over x minus 3. Now, some of you guys got to remember your fraction rules. When you multiply a fraction by a whole number, the only thing that gets multiplied is the numerator, not both. So that's the exact same right there. Okay, now we can, based on the parent graph, 1 over x, we can now say what's going to happen. Okay, so here we would have that it's going right 3, not down 3, because, so let me put the transformation here. So you would have an A out in front, that would be my vertical stretch. And then we have here x minus h, that is what's going to move it left and right. And then you would have a plus k on the outside. Now if there wasn't an A, then there wouldn't be parentheses, okay? So the plus k would be on the very outside, not in the fraction. So this is going right 3 because of this right here. Minus 3 means right. And then it has a vertical stretch by 2. Or the next example is f of x equals 3x plus 5 over x plus 2. All right, this is where it becomes a little tricky, okay? You need to do long division. Long division. Why do I need to do long division? Because I need to divide, and that needs to be a 1 on the top. Okay, so let's see what's happening here. So let's long divide this. We have 3x plus 5 on the inside and x plus 2 on the outside. So when I do my long division, x times what gives me 3x? Well, the answer is 3. Then I multiply. 3 times x is 3x. 3 times 2 is 6. When I do long division, I change my signs. Change, because we're subtracting. Okay, so then this cancels. 5 minus 6 is -1. And x, so when you're doing long division, it's all about that first term. This x will never be able to be 1. So that's my remainder. So the answer is 3 plus -1 over x plus 2. Okay, we do want that to happen, but I can't have a -1. So I'm going to take that out, and it's actually 3 minus 1 over x plus 2. All right, so what is happening? I'm going up 3 because my k value is positive. This is my k value right here. There's not, that negative's not in front of it. This on the denominator is going left and right, so that's going to be left 2. And then the very last thing, if I negate it all, you are going to flip it over the x. So 3 things happened here. Up 3, left 2, and flip it over the x. All right. Let's keep this train rolling. So asymptotes and holes. And then we'll go back to that word graphing that we kind of skipped over. So this right here is what causes issues in my rational function. So we're going to start off with some definitions. A lot of writing today. So the vertical asymptote is the line x approaches from left or right as y approaches plus or minus infinity. So that's the vertical asymptote. Vertical asymptote is the line x approaches from left to right as y approaches infinity or negative infinity. Okay? So, side note, to find the, and I'm going to abbreviate it as VA, to find the vertical asymptote, the top and bottom must be factored. So if you need to relearn how to factor, I made a great video on that. Unit P, day 5, I believe. Okay. The other thing is the vertical asymptote is everything that causes the denominator to be 0 as long as it is not a whole. And you're probably thinking, what the heck is a whole, man? Well, a whole is the common factor that's on the top and the bottom. So if something is on the top and something is on the bottom and it cancels out, that's a whole, and it is no longer a vertical asymptote in the bottom because it's a whole, not an asymptote, okay? So holes exist if it is a common factor on the top and bottom of the fraction. All right, so let's just see an example of this. All right, so here's the example. Find the vertical asymptotes and wholes. So f of x equals 2x squared plus 5x plus 3. A little tricky on the top because that leading coefficient's not 1. X squared plus 4x plus 3. Okay, guys, make sure you know how to factor. This unit's going to be hard if you don't. All right, you know how I like to factor, and so I'm going to do me. You do you, boo. However you get it done. We got to both get the same answer. So I would pause your video and see if you can factor the top and see if you can factor the bottom. All right, welcome back. Let's see if you got it right. 2 times 3, that's a 6. And since it's positive, that means it adds to give me the middle. The factors of 6 are 1 and 6, 2 and 3. 1 plus 6 does not equal 5, so it's not that one. 2 plus 3, well, that guy equals 5. So the top is going to factor to, I'm not going to write it yet because I'm not finished, x plus 2 and x plus 3. I wish it was that easy, but with my method, you have to divide by the leading coefficient, the a value, the leading term, which is 2 here. So I divide, I reduce, and then I slide. So the first fraction reduces to x plus 1, and the second fraction reduces to nothing, so I have to slide that denominator to the front of x. And it factors so beautifully. Okay? So, it's a crooked line. Oh, Lord. All right, so 1 times 3 is 3. That means it adds to give me 4. Well, 3 is a prime number, so there's only one way to get 3. 1 plus 3 equals 4. And since the leading coefficient is 1, I don't really have to worry about dividing by 1 because it's just going to reduce to whatever it was. Bam. All right, so here we are. You have a common factor, these x plus 1s. Now, they don't have to be right on top of each other. They could have wrote it the other way, and they would have still canceled as long as there's 1 on the top and 1 on the bottom. But if there was another x plus 1 on the bottom, that wouldn't cancel because you can only cancel 1 with 1. 1 for 1. This isn't a 2 for 1 deal. No BOGO. Okay? So, those right there are my whole. Okay, and then this guy, what's remaining, so this red is my vertical asymptote. But it's not that easy we gotta write it. So to get the whole, because we need both x and y, so the x value is just x plus 1 equals 0. So the x value is -1. So to get the y value, you have to factor, oh, we already did that. Then you have to cancel, and then whatever's left over, you plug in. That sounds a lot like limits, my friends. I factored, I canceled, and now I'm going to plug in -1. -1 on the top gives me 1. -1 on the bottom gives me 2, 1/2. There's my whole. And then the vertical asymptote's easy. Vertical asymptote is equal the same way. X plus 3 equals 0. So x equals -3. That right there is my vertical asymptote. If I were to graph this, it will be going straight up and down through -3. So beautiful. All right. Time for the horizontal asymptotes. Okay. There's 3 types, but we're only talking about 2, vertical and horizontal. We're going to talk about the end behavior one next class, I think. I'm not sure. Probably. But there's another one. I bet you can't wait. Horizontal asymptotes. I say it wrong. Love it. Okay, makes me sound super intelligent. Is the line y equals b, so the vertical was x equals, and you could say c, whatever letter your heart desires. It's a number. B is a random number. If y approaches that number b as x approaches plus or minus infinity. Okay, so here's the thing. A rational function can have more than one vertical asymptote, but only at most one horizontal asymptote. Okay, now the thing about I just want to reiterate this, when we're writing these vertical and horizontal asymptotes, you have to know which one is x and which one's y. Vertical is x, horizontal is y. Now, I have some fun acronyms that I use to remember this, okay? So, how to know what it is. And you should have already learned this. How to find horizontal asymptotes based on the degree. Okay, the degree, again, from Miss Marshall's unit, is the highest exponent in simplified form. Okay, so I'm not talking about when it's canceled. I'm talking about the OG problem, where it's all factored, not factored, and it's in simplest form, and it's a beautiful quadratic, cubic, whatever on top, and a beautiful quadratic, cubic, linear on the bottom. Okay, not factors. Okay, so how to find the horizontal based on the degree. If it is bigger on bottom, it equals 0. Bigger on bottom equals 0. B-O-B-O. Bobo. Bigger on bottom equals 0. Bobo. Okay? If it's bigger on top, it equals none. There is none. Bigger, or let me underline it in this color. Bigger on top equals none. Bottom. Bobo and bottom. Bigger on bottom equals 0. Bigger on top equals none. And there's one more. This one's a harder one. Exponents are the same equals you divide the coefficients, the numbers in front of the degrees, the leading coefficients. Exponents are the same, divide coefficients. Eats DC. Eats DC. Okay, so Bobo, bigger on bottom equals 0. Bottom, bigger on top equals none. Eats DC, divide coefficients. Bigger on top, that's top heavy. Bigger on bottom, that's bottom heavy. Bobo, bottom, eats DC. Bobo, bottom, eats DC. All right. So, just to talk about horizontal asymptotes, that great little jig I did there. If I go back to this original example where I was talking about the vertical asymptotes, let's talk about the horizontal asymptote. So, looking at this, my exponents, the highest exponents, they're squareds on both the top and the bottom. So that's exponents are the same. Exponents are the same. Divide coefficients. So my horizontal asymptote, the two coefficients are 2 over 1. So the horizontal asymptote is y equals 2. Vertical was x equals -3, and then you had a hole. All right, we're just going to do a few examples, and then we're finished. So Here's the examples. I'm going to write all 4 of them up there, and I highly suggest you pause the video and see if you can do them, okay? So find the vertical asymptotes, horizontal, and holes. All right, so 4 of them. Here's the first one. F of x equals 3x minus 1 over x minus 2. Okay, here's the second one. F of x equals x minus 5 over x squared plus 6x plus 5. Here's the third one. 2x over x squared plus 4x, and technically I should have a name, we'll call it g of x. And then the last rational function is h of x equals x cubed plus 4x squared over 4x cubed plus 12x squared minus 16x. All right, write those down. Please try to see if you can do it. You should be able to find the vertical asymptotes and the holes, factor, cancel, all that fun stuff. And then my new thing, Bobo, Botan, etc. All right, so welcome back. I hope you have your answers. Here is, this one's easy. There is nothing to factor. You can't factor something if it don't factor. So this one, my vertical, so nothing cancels because there's not even a GCF. So my vertical asymptote is x equals 1. That came from here, setting the denominator equal to 0, and then solving. Okay, so holes, since nothing canceled, it is none. And my horizontal, I almost wrote vertical, let's try that again. The horizontal asymptote, so my exponent on top is 1, my exponent on the bottom is also 1, so this one is eats DC, exponents are the same. That means I have to divide the coefficients, 3 divided by 1, so it's y equals 3, because there's also a 1 right here. 3 divided by 1, you divide the coefficient in front of that degree. All right. Number 2, this one, got to factor the bottom. I have an x minus 5 here, and then I have x plus 5 and x plus 1. Easy factor. Oh, well, those are not the same either, y'all. I can't cross out x minus 5 and x plus 5. They have to be exactly the same. So my vertical, I have 2 vertical asymptotes. I have one at x equals negative 5 and x equals negative 1. Okay? The holes are none, because nothing canceled. And my horizontal, all right, so let's look at this. This top is degree of 1. And this bottom is 2. So that means I'm bigger on bottom. Bobo. Bigger on bottom equals 0. So it is y equals 0. Ooh, yeah. All right. Number 3. Why am I yelling? It's fun. All right. I can't factor the top. I can factor the bottom. So the top stays 2x because there's a GCF of x. So I take that out and it's x plus 4. So I do have a common factor. An x on the top and the x on the bottom because they both don't have anything added with them. I couldn't cross them out on number 2 because there was a minus 5 and a plus 5. Okay, there's nothing being added to the x and there's nothing being added to the x on the bottom. So I do have a hole this time. Woo woo. So my vertical asymptote then is just x equals negative 4. My hole is going to happen, that's 0. So if I I cancel them. If I plug in 0, I get 2 over 4. 2 over 4 is 1/2. And then my horizontal asymptote. So let's look at this. Ooh, another Bobo. Bigger on bottom equals 0. All right. All right. We are going to factor the last one, and then we'll be done. We'll talk more about domain and range next class. Sorry, I didn't know why I scrolled. Here we go. Let's take out an x squared at the top. So I get x plus 4. I have yet to use a calculator, just FYI, my friends. So on the bottom, though, I have x. If I take that out, and then I have, ooh, I can take out even bigger, a 4x. And then I'm left with x squared plus 3x minus 4. Now that's an easy. I'm going to split that x squared to x times x because that's going to help me with my factoring and canceling and all that stuff. And then I have a 4x down here, and this is x minus 1x plus 4. I have two holes. I have a hole here, one of these x's, just one, and I have a hole here. So those x's, I don't know why I picked the second one, it doesn't matter. So I have two holes. So then my vertical asymptote is x equals 1. And then my holes are, one is happening at 0, and the other one is happening at -4. Okay, so when I factored and I canceled, if I plug in 0, I get 0, 0 because of that x still left on the top. And if I plug in my -4, I get -4 on top over 4 times -5, which is -4 over -20, which is 1/5. And then my vertical, so the vertical asymptote, looking at the OG problem, exponents eats DC. Exponents are the same, divide coefficient, so the y equals 1/4. That is my horizontal. I don't know why I keep labeling it as vertical. Might be. Okay. Ugh. All right. Let me just make sure I did what I wanted to do. I think I did. The graphing by transformations. We're going to get more into graphing. I really just wanted you to be able to do the transformations. And then the domain and range, we're going to get into more detail also in your day 2 video. So it's been a pleasure. I'll see you. Probably was too long, but you know what? It is what it is, my friends. Bye.